We now discuss the solution of a problem from the section Differential Calculus. The problem is related to twice differentiable even functions. This question has appeared in the joint entrance examination main held on 29th June 2022 in the second shift. The given question is, let f and g be twice differentiable even functions on the open interval -2 to 2 such that f of 1 by 4 is 0, f of 1 by 2 is 0, f of 1 is equal to 1, and g of 3 by 4 is equal to 0, g of 1 is equal to 2, then the minimum number of solutions of f of x multiplied by g double prime x plus f prime x multiplied by g prime x is equal to 0 in the interval, open interval, -2 to 2 is equal to. We are given two functions f and g, and it is given that they are twice differentiable even functions in the interval -2 to 2, such that 1 by 4 is a solution of f of x, f of 1 by 2 is a solution of f of x, and f of 1 is equal to 1, and 3 by 4 is a solution of g of x, g of 1 is equal to 2. Required to find the minimum number of solutions of f of x into g double prime x plus f prime x multiplied by g prime x is equal to 0 in the open interval -2 to 2. We now discuss the solution of the problem in detail. Given f and g are twice differentiable even functions on the open interval -2 to 2. And f and g are twice differentiable means f prime x, f double prime x exists in -2 to 2. Similarly, g prime x and g double prime x exists in the open interval -2 to 2, and f and g are both even functions. Because they are even, f of minus x is equal to f of x, g and g of minus x is equal to g of x for all x belongs to -2 to 2. That is the meaning of the even functions. Right. Given f of 1 by 4 is equal to 0. That means 1 by 4 is a root of f of x. And f of 1 by 2 is 0. 1 by 2 is a root of f of x. f of 1 is equal to 1. 1 is not a root of f of x. G of 3 by 4 is equal to 0 means 3 by 4 is a root of g of x. G of 1 is equal to 2. 1 is not a root of g of x. So we use the even nature of the functions. F of 1 by 4 is equal to f of minus 1 by 4 is equal to 0 because f of x is equal to f of minus x because it is an even function. So also for 1 by 2, f of 1 by 2 is equal to f of minus 1 by 2 is equal to 0 because f is an even function. So we have how many roots? 1 by 4, second minus 1 by 4, third 1 by 2, fourth minus 1 by 2. So f of x has at least 4 roots in the open interval -2 to +2. This is for the function f. Let's consider now the second function g. G of 3 by 4 is equal to g of minus 3 by 4 is equal to 0 because g is an even function. So this will tell you g of x has at least 2 roots in -2 to 2. And remember here 1 is not a root of f of 1 because f of 1 is not 0. And 1 is not a root of g of x because g of 1 is not 0. Agreed. So now let's recall a result. The result says g, suppose g is a real valued function defined on set of real numbers. And if g of x has n distinct roots in R, that means it has n distinct real roots, then g prime x has n minus 1 distinct real roots in R. That means the number of roots will be reduced by 1 in the case of g prime x. So now we apply here. G of x has at least 2 roots in minus 2 to 2. This will imply g prime x has minimum at least 1 root in the interval, open interval minus 2 to 2. We continue in the next slide. Right. In the last slide, we have shown you f of x has at least 4 roots in minus 2 to 2, and g prime x has at least 1 root in minus 2 to 2. And now required to find the minimum number of solutions, minimum number of roots of this equation. F of x into g double prime x plus f prime x into g prime x is equal to 0 in the interval minus 2 to 2. So notice that this one, f of x, g double prime x multiplied by plus f prime x multiplied by g prime x is the derivative of differential of f of x multiplied by g prime x. F of x multiplied by g prime x, that you differentiate once again. Then you will get this one. And we need not worry about the existence of these functions, because f and g are given to be twice differentiable. That means f prime x exists and f double prime exists. F double prime and g prime exists, g double prime exists in the open interval minus 2 to 2. Therefore, all these things are there. Therefore, no need to worry. So now required to find the minimum number of solutions of this equation means this will imply now f of x into g prime x has f of x has at least 4 roots, g prime x has at least 1 root. The product will have at least 4 plus 1, 5 roots in the interval minus 2 to 2. But now we take that and take the derivative, first differential. So this will imply, therefore, f of x, g prime x, whole prime. Again differentiate, then it will have a minimum 5 minus 1, that is 4 roots. 5 minus 1, that is 4 roots. So, but this is same as f of x into g double prime x plus f prime x multiplied by g prime x. So this will imply f of x, g double prime x plus f prime x multiplied by g prime x is equal to 0, has minimum 4 roots, at least 4 roots in the interval minus 2 to 2. So thus we answer the minimum number of solutions of f of x into g double prime x plus f prime x multiplied by g prime x is equal to 0 in the open interval minus 2 to 2 is 4. That is our answer. The answer is 4. The answer to this question is 4, and that is the detailed discussion of the solution of the problem from the differential calculus on the differentiation of on the subsection differentiation, right? And it is not a easy question. It is definitely difficult question, but not that difficult. But if you know that result, if j of x has n real roots, distinct real roots, then its derivative g prime x has n minus 1 distinct real roots. If you know that result, then this result will be easy. That is the detailed discussion of the solution of the problem. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.